Hello there, and welcome everybody to another edition of Starry Skies, the magazine programme that tells you all about what you can see in the night sky in this chilly month of January. I'm Mark Hardacre.
And I'm Steve Tonkin. So what can we see in this chilly month? Well, we're going to come to that later, aren't we?
We will, yeah. But let's start by wishing all our listeners a very happy new year. And we hope that 2026,
yeah.
in the wrong century, Steve. Let's hope it turns out to be a happy, healthy, prosperous and pleasant new year for you and your families.
Indeed. And January is named after the Roman god Janus, who is looking forward and looking back.
Aha.
And that's where we're going to start. We're going to look back and then look forward.
Yeah. And let's hope that we can get, in this wonderful new year, some fine, clear skies, shall we?
Indeed.
Some dark skies. And we are very fortunate here to have dark skies, aren't we, in the Forest FM area? Cranbourne Chase, dark sky area, right on our doorstep.
Indeed.
And
I have a special affinity for that.
Yes, well, you do work there.
Yes.
But it's also important, not just for astronomers. Dark skies are important for our fellow travellers on this planet, Steve, right?
I came into this dark sky advocacy, or responsible lighting advocacy, from astronomy, but now I'm there for biodiversity.
Yep. Yeah. So we all need that daily rhythm, don't we, of
nature.
Dark light and dark. Nature does, not just human beings, not just astronomers, but birds, butterflies, insects. And,
nature needs the night, is the one to remember.
And we shouldn't be hearing birds singing at 2 a.m. I was listening the other day, 2 a.m., robins tweeting in our trees. That's not right, is it?
No, of course it's not right. The thing is, it's very, very easy to get the lighting right, and it doesn't mean no light. But maybe we'll talk about that some other time.
We will, yeah. Anyway, so 2026, just briefly, it's going to be a fascinating year for stargazers, and there's lots to see throughout the year. So one highlight will be our Messier challenge in March. Steve, that's going to be fun, isn't it? Where we all gather up in the New Forest to try and count those 110 fuzzy objects in Charles Messier's catalogue. That's a bit of a fun night, isn't it?
It is, even though it's impossible to do it from this latitude, to get all 110, but we can do our best.
So we call it a challenge rather than a marathon. We'll probably, last year we did 107, which is pretty good.
That's excellent.
It really was good, yeah. And then, of course, in June, we're going to see a nice conjunction. That will be very, very nice to see. A close approach of two of the brightest planets, Jupiter and Venus, will be low in the western sky in June. More about that nearer the time. This year also, we're going to have a number of favourable meteor showers. Last year was a bit of a washout with the Perseids, wasn't it?
Well, it was too much moon. Yeah.
But this year is going to be great. There's a new moon just around the time of the 12th. Of course, because we'll see that causes an eclipse this month. So look out for the Perseids in August and the Geminids again in December. So,
best meteor shower of the year.
Absolutely, yeah. So August offers us two eclipses. First one is that huge partial, which is on Wednesday, the 12th of August. So we're going to look forward to that.
Indeed. And if you want to get a total, I'm afraid you're going to have to leave these islands and go west a little bit.
Yep. You can go out into the North Sea, up to Iceland, or even down to Spain and Mallorca. Yep. So if you're on Mallorca during the middle of August, good lucky you, because you're going to have a total eclipse in the evening of Wednesday the 12th. And 2 weeks after that, guess what? We're going to have a partial lunar eclipse. Often happens like that, doesn't it? They often come in pairs. Yeah. First you have a lunar eclipse, a solar eclipse, and then 2 weeks later the full moon is eclipsed, and this happens on the 28th of August this year with a partial lunar eclipse. 3:30 in the morning, so you've got to be a bit up early for that one.
Yeah, but it'll be worth getting up to, and it'll be light anyway by then. It'll be getting light, so it'll be actually lovely to see.
Yeah.
And, well, we know it's got to be getting light if you're seeing the moon, and let's say in eclipse, because that will only happen when the moon is setting or rising as the sun is rising or setting.
Yep. So it'll be good to see. Well, all these things we're going to cover later in the year, of course. We've got the Orionid meteors in October. We'll look out for those. But keep listening to Forest FM. We'll keep you updated, and keep checking our Forest FM fan page and all our local Astronomical Society pages. We'll put all the stuff on there, won't we?
Indeed.
So what about January? What about this chilly month?
Well, we got the new moon, which is the best time for stargazing, usually, which is on the 18th. So, from about the 10th to the 25th, 26th is going to be your stargazing window.
Yep. And we've just had the full moon on Saturday, just Saturday the 3rd of January, just gone, high in the constellation of Gemini. And through this week, it's going to be waning. That means, of course, it's getting less and less in phase, less and less in size, and it's passing further to the west in the evening sky, rising later and later. So by the end of, as we get towards the 11th, 12th of January, the moon will have more or less disappeared from the sky. What else have we got up there? Brilliant Jupiter, right?
Oh, king of planets.
Yep.
For a reason.
Absolutely.
Yeah, it's absolutely gorgeous. The only planet that gets brighter than that is Venus, and that's not really visible at the moment, as you said earlier. We'll wait for that later in the year.
Yeah. You can't miss Jupiter, though. It's really, really brilliant. If you put your head out the door any time, late evening, there it'll be, right above, well, not above us, but towards the south.
Yeah.
And with a pair of binoculars, again, you'll see those 4 Galilean moons and a hint of the planet's disk. Yeah. Even with the smallest binoculars, you can see that Jupiter is not a star.
Yes, and you can also see the Galilean moons with very, very modest equipment.
Yeah.
I've actually seen them with toy plastic lensed 4 times binoculars, which is just... so, if you've got halfway decent, proper binoculars, no problem seeing them at all.
Sometimes there's 4 of them, of course, but sometimes we can only see 2 or 3 as the planets, as the moons move behind or in front of the planet. They disappear for a while. So if you can only see 2 or 3, just wait for an hour or 2 and you'll see one or the other pop up from behind the planet. Often happens. What else? We've got Saturn coming to the end of its period of visibility, so it's still there, but not for much longer, right?
No, but at least it's easy to find, because it's about the only thing you can see in that area of the sky with naked eye.
Yeah, so look out the window, look out towards the west after sunset, around 9 o'clock, or a bit earlier than that really, 8, 9 o'clock towards the middle of the month. And there, below the square of Pegasus, you should see Saturn, just by itself in a barren area of the sky, right?
It is. I mean, excuse me. You will see a few other stars around that, but it's good. It's not very good though at the moment because its rings still almost edge on to us.
Yeah.
But when it comes back next or later this year, then we're going to see it much nicer, and it'll look brighter as well.
Yeah. And what about the night sky itself? We've got the constellations, of course, our usual ones, and, of course, the night sky of winter, Steve, is dominated by Orion.
One of my favourite constellations, and it's one that I think most people can easily recognise. You've got the 3 stars of the belt. You've got very, very bright, orangey-looking Betelgeuse as the top left-hand shoulder as we look at it, and then diagonally opposite that, the right-hand foot is a hot bluish white star called Rigel.
And those two are so contrasty, aren't they? One is hot white, blue-white Rigel, and Betelgeuse with its cool red-orange glow. They really are quite contrasting and very bright, of course. Yeah. Now, hanging below the belt, so the 3 stars that make the belt, hanging below there is what we call the Sword of Orion. And if you look carefully, the middle one of those 3 stars hanging down is rather fuzzy. It's a fuzzy little patch. And that is also one of Charles Messier's objects, which he catalogued as Messier 42 or M42. And this is the Orion Nebula. And that really is an enormous mass of gas, isn't it?
Oh, it's absolutely huge, which is the only reason we can see it, actually, because its distance across is about 6 times the distance from here to the nearest star to us.
And that's just all gas.
And that's just all gas. And if you were there, you wouldn't be able to see it. It would look just like a vacuum.
Right.
But because there's so much of it, and we're seeing it from a distance, we can actually see this stuff, as it were.
Yeah, and it's about 1,350 light years, so it's quite away from us. And you imagine, because it's quite a big patch in the sky, isn't it? It's 25 light years across. This is a heck of a size. And this gas is swirling. In binoculars, I think it looks like, when you've got a cup of tea and you pour your first drop of milk in and it swirls around the top of the cup. I think that's what M42 looks like with binoculars, don't you?
Well, I don't drink milk, so I don't know. But I get what you mean. From your go to your favourite coffee place where the barista does a swirl. You could probably get them to do an Orion Nebula for you. And
it has that same milkiness with binoculars.
It does. It really. It's lovely, and it's so clearly not a star.
Yeah.
And the bigger your binoculars and the more you can magnify it, the more and more structure you can start to see in it.
And even with a larger telescope, something like a 6 or an 8-inch telescope, the detail in the cloud, you can see little swirls coming off here and twists and curls. And right in the middle is a quadruple star, right? Theta Orionis.
Yes, what we can see with ordinary binoculars, you'll normally see 2, maybe 3 of them. Magnify up to about 16, 20 times, you'll be able to see all 4.
Yep.
But if you have something bigger, you'll actually see there's actually more than 4 there.
Yep.
And that little group of stars is the stars that illuminates that entire 25 light-year diameter blob, I suppose. Yep. And it's bright there. I mean, it's actually part of something much, much bigger. And that's you can only see it. It's like imagine a huge apple, and somebody's taken a little bite out of it, and the Orion Nebula is that little bite in this much, much bigger.
And the rest we can see only with cameras, long exposure
cameras, and ideally special filters as well.
Yeah. So when you're looking at that Orion Nebula, what are we actually seeing, Steve? We're seeing the gas, but what's actually going on there?
Well, this gas is gradually collapsing under gravity because everything with mass attracts everything else with mass. And so it's and when it collapses, like any gas, it gets hot.
Yeah.
You compress a gas, it gets hot, and little clumps of it will get hot enough that ultimately they get up to about 25 million degrees, which is hot enough for this, mostly hydrogen, to start a nuclear reaction. And it fuses into helium, and what you have essentially there is a star forming, and you get other stuff coming round it, like little disks. They're called protoplanetary disks, and they eventually form planets, because all this stuff we're looking at is not original. This stuff has already been through 2 or 3 stars.
Right.
And so we're looking at stardust, or nuclear waste, which is then creating
new
like
stars. Sellafield, is it?
No, nothing like Sellafield, but it's which is then creating new stars. So this is we call it a stellar nursery, a place where stars are being born, and eventually, if you look above or below it with your binoculars, you'll see there's little clusters of stars. And those are called open clusters for fairly obvious reasons when you look at them. And the Orion Nebula will become like that. It'll become a cluster of stars which will be open. It won't be very, very tightly compressed.
So that cloud of gas is not pure hydrogen. It's got hydrogen and all the other bits of elements that have been formed in other stars blasted out millennia ago.
It's also got amino acids in it.
Right. So as it collapses, it forms, of course, the stars. And as you said then, the protoplanets that will form. So we'll have new Earths forming out there. Right, so that's a stellar nursery. And as they all form, as these stars collapse out of the Orion Nebula over the next several million years, we're going to form a star cluster, right, as you just said.
Yep.
So star clusters. And that's a bit of a theme for today, isn't it? We're going to talk about star clusters.
Oh, this is the best time of year from them. The winter, you've just got these sparkling clusters. Once you start looking around for them, the problem isn't finding them. The problem is identifying all the ones you can see.
Yeah, there's lots and lots up there. And these newly formed stars, so as the Orion Nebula collapses, these stars are all going to clump together. What happens to them then? Do they eventually all drift apart? And
ultimately, yes. I mean, our sun was once part of a star cluster, something you can see with your naked eye, really. The thing we often talk about, those 7 bright stars of of the Big Dipper.
Yep.
They are were once part of a star cluster. Well, they sort of still are, but they've really opened up. Because what happens is, when you get stars in that group, they're all sort of orbiting around each other. But if you could imagine you've got a big person and a little person swinging around each other on a rope, and then the rope snaps, what happens is the little person is going to go a lot further and faster than the big person. And that is effectively what's happening. Yeah. It's called mass differentiation, and basically the stars just get flung around, flung apart.
I like to think of when stars form in clusters. It's like when the kids are at home.
Yeah.
As they get bigger and they become teenage, brothers and sisters are squabbling and fighting, and eventually they get in each other's way and throw each other out the house and drift into life. And that's a bit like star clusters, isn't it?
I guess so.
They all drift apart like teenagers and become grown up, like our sun is a grown up adult star, isn't it now?
Yes. I guess so. Yeah, I haven't thought of it like that before. That's a good one. Yeah.
Good little. Anyway, and is the Orion Nebula are there more emission nebulas like this in the sky? Hydrogen?
Again, there's loads of them.
Right.
They're a bunch of lots of hydrogen. They're called emission nebulae because they what happens is you get a very energetic star near that, and it excites the electrons in the hydrogen gas,
lights them up.
So they sort of like move out in their orbit around the nucleus of the atom, and as they fall back, they emit usually red light.
Yeah. And
that's what we see. So it's this glowing hydrogen.
Right.
And when you see red in astronomical images, that is hydrogen.
Yeah. Okay, so we know now that the Orion Nebula is going to collapse into an open cluster in millennia. Mm-hmm. Let's see if we can find one in the sky. Shall we let's start back at Orion, back to the belt again, and go up from the belt, up and to the right? Go up through Aldebaran, past the bright orange star in Taurus, and keep on going till you find the Pleiades. Right now, there is a classic open cluster. So the Pleiades, Steve, used to be a gas cloud like the Orion Nebula, is that right?
It did. That would have been hundreds of millions of years ago, probably. Right. Or maybe not that much, but certainly millions of years ago.
When it was a gas cloud. And now what we see there is the seven sisters, as they're called, the seven bright stars that form this cluster. But with a pair of binoculars, you can see, 100 at least?
I don't think I've seen 100 in sort of normal-sized binoculars, but certainly 40 or 50, depending on how clear the sky is. It's very, very... your seven sisters certainly become your 40 sisters.
At least that. And with other studies have shown there's around 1,000 members of this cluster in total.
That's enormous.
Yeah, about 450 light years away from us, so it's quite far away, not as far away as the Orion Nebula, but still quite far away, but very young, only 100 million years old. So, when the dinosaurs were wandering around, they could look up and they would not have seen the Pleiades. They would have seen a gas cloud up there, right?
Oh, excuse me.
Anyway, so that's the Pleiades. Nearby, of course, we've also got the Hyades. Tell us about, what's the Hyades? Is that the same, or what's the Hyades?
The Hyades is another open cluster. It's like a V shape, and it's where Aldebaran is at the tip of one of the legs of the V, as it were.
Yeah.
And it's actually not part of the cluster. It's a foreground star.
Right.
And there's a number of reasons you can tell that, even if you can't measure the distance, is that these open cluster stars tend to be hot, very whitish stars, and Aldebaran isn't. It's a very old star. It's an orange star. So it's clearly formed in a different part of the sky.
But the Hyades is a much older cluster than the Pleiades. It's more spread out. It's nearer to us, of course.
Much nearer to us,
Much nearer. But it's also a much older cluster. It's about 625 million years old, whereas the Pleiades is only 100. So they're spread out, and they're also older stars. So they're not all like the Pleiades, that brilliant blue-white colour, are they? There's some orange giants in there.
Yellowish ones.
Yeah, that have all turned... they're starting to show their age.
They're beginning to, but they're still, compared to Aldebaran,
Yeah.
they're still clearly not that old, so that's lovely. The Hyades also, if we're looking ahead, they are the April rainers.
They are what?
In the song Green Grow the Rushes, where you get 8 for the April rainers. It's one of those old counting songs. And the April rainers are the Hyades. And you see in April, the Hyades set just after the sun sets. And
you get all this for no extra charge, listeners. You know, this man knows things about the stars that most people have forgotten. I've never heard of that before.
Have you not?
Never.
Oh, right.
April rainers. I shall add that to my inventory of things to talk about.
Because what happens when it sets just after the sun, so the last you see of it in the spring is when it's April and you get the April showers. On and on for hours and hours, as Flanders and Swan said, yeah.
So the Hyades, the Pleiades was catalogued by Messier as M45, Messier 45. Hyades not classified at all by
no,
Messier.
but classified by other people who like Per Collender, who is one of my favourite classifiers of clusters.
Yes.
Or Melot.
Yes. So
Patrick Moore. Patrick Moore catalogue is not called the Moore catalogue, it's called the Caldwell catalogue.
Yep.
Actually, his full surname was Caldwell Moore.
Yep. So the Hyades is Caldwell 41. It's also called Colander 50. And also called Melot 25. So these are all different catalogues that astronomers confusingly use to identify things in the sky.
But the Colander ones are great.
Yes, they are.
Because the Colander clusters, there's a few of them around, and there's 2 really nice ones in Orion.
Right.
So first of all, if you go to Orion's belt...
It's getting excited yet, really, are you?
Oh, yeah. You look at Orion's belt, and most people, astronomers, just use Orion's belt. Oh, yeah, right. Now we go below that and we see this wonderful nebula. Don't. Look at the belt with binoculars. It is this beautiful cluster of stars. It's big. Yep. It'll just about overflow your field of view. Bright, bluish-white... mostly blue-white stars, and that is Colander 70, and it's absolutely gorgeous cluster. I spend more time looking at that than I do at the nebula, actually.
Yeah. It's a nice collection. It's probably, 50 stars, 40, 50 stars tops. Yeah.
Oh, more than that.
Is there?
Yeah, yeah. And you look at it, there's between the 2 left-hand stars of the, 2 right-hand stars of the belt, there's this wonderful curve, and if you follow that, if you imagine that as a swan's neck, and then the wing comes up between the other 2 stars, the middle star and the left-hand star,
right.
And that, it's just, you can find these little groups for yourself. I just think it's utterly lovely.
10 by 50 binoculars?
10 by 50 binoculars is great. You don't want to magnify too much because it'll overflow the field of view.
So 10 by 50s, if I point them at the belt stars, it will just about fill a 10 by 50 binocular field of view.
Yeah.
So you get the whole of this Colander 70 star cluster in the field of view if you point at the belt.
Indeed.
Take a dark night, of course.
And, yeah. You want a decent dark night. And the other one is Colander 69, which is Orion's head.
Aha!
And you look at that, now it's not nearly as impressive. But
so where do I find that then?
So if you look, you've got Betelgeuse, and then the other shoulder is Bellatrix, and like little isosceles triangle above that, isosceles being 2 legs the same size, above that is this little cluster of stars, looks like sometimes called Orion's head, and this is Colander 69, sometimes called the Messier cluster, and look at that in binoculars, and what you will see again is different star colours. Lovely, these lovely different stars in there.
Yeah. So star clusters, great to find. We've mentioned Orion there. We've mentioned the 2 in Taurus, the Bull, but there's 3 or 4 in Auriga, M37, M36, and M38.
Yep.
Wonderful to find. And then later in the evening, around midnight, 1 o'clock in the evening in January, have a look to the east, and you'll see the constellation of Cancer rising there.
Yeah.
And in the middle of that, you'll find M44, which is the Beehive cluster.
Yes. Otherwise known as Nephilion.
Which I only learned this morning.
Which the ancient Greeks called it. And that means the little cloud. And that is what you'll see with your naked eye. You'll see a little cloud there.
but with binoculars again, full peppered with stars.
Yeah.
These star clusters at this time of the year are brilliant, really, really.
And you'll see what we were talking about earlier. In that, you'll see the brighter stars are near the middle and the fainter stars at the outside.
Yeah.
It's this thing about, the faint ones being sort of thrown out by gravity as this
Absolutely
cluster expands.
While we're looking at the Pleiades, January is also a good time to look for faint Uranus. Because for several months it's going to be pretty close to the Pleiades. Again, we'll put a map on our Forest FM fan page of how to find it. But if you use your binoculars, look a little bit below the Pleiades, you'll find 3 stars in a row. Average brightness in binoculars. The one to the right will be Uranus, and if you follow that from night to night, you'll see it slowly moves across the sky. Not many people actually can find Uranus. It's usually quite tricky to find, but its proximity to the Pleiades right now means it's relatively easy to find. So have a look for that, and do let us know if you find it, because only a tiny fraction of the population of the world has ever seen it, right?
Indeed, but it is relatively easy, and it's in binoculars. It's certainly easily bright enough to figure. It's just identifying it.
That's it, finding it amongst the crowd of other stars up there. Anyway, all the stars and constellations that we've mentioned today can be seen on our monthly star chart, which will be posted on the Forest FM fan page, as well as online at Fordingbridge Astronomers and Wessex Astronomical Society. And that'll be showing the stars around mid-month, around the 15th of January at about 10 p.m.
And all of these societies run stargazing evenings, which you can come along to. And also, Mark mentioned Cranbourne Chase as well. Cranbourne Chase National Landscape, which is the Dark Sky Reserve, also runs stargazing evenings. Look at the various websites, and you will be able to come along to something if it's a nice clear night and enjoy what there is to show, because it's lovely out there. It really is.
It is. Come and see it. Of course, we need some decent weather, so we just hope for some nice high-pressure, frosty, clear evenings. Let's see what happens. Anyway, if you're interested in finding out more about astronomy, please contact us at our local astronomical societies and clubs. Fordingbridge Astronomers meets every third Wednesday in the month. We meet at the Elm Tree in Hightown in Ringwood. Next one is the 21st of January, I think. Come and see us.
The Wessex Astronomical Society meets at the Allendale Centre in Wimborne, and that's on the first Tuesday of the month.
Okay, we just missed that one for this month of January, but never mind.
Oh, yes, so we have.
And then Cranbourne Chase Astronomy Club meets on the second Wednesday of the month at the Grosvenor Hotel in the centre of Shaftesbury. All 3 clubs love new members.
Indeed. You don't need anything other than useful to have one working eye, and that's really it. Come along to our thing. We will share our stuff with you because we love showing it off.
And it's also a great chance to come along, test out various bits of kit without buying first. So come along and enjoy the sky with us.
And if you did get telescope or binoculars for Christmas and you want to clue how to use them more effectively, again, bring them along. We'll show you that as well.
Very good. We wish you a happy New Year 2026 and look forward to seeing you next month for another edition of Starry Skies. So until then, it's goodbye from me, Mark Hardacre.
And from me, Steve Tonkin.
And as usual, clear skies.